is Vireakboth.
I am Limvannaksakpheabondith.
I am Chilong CHOV. We are freshmen from Civil Engineering Department of Paragon International University Academic Year 2023-2024. And this is our presentation for the Spaghetti Bridge Challenge. But first, let us explain you some regulation and criteria of the challenge first. So any students who are interested can participate, and one group can consist up to 3 people. And any pastel type, hot glue, clear tape, or any material that used for artistic purpose are also allowed.
What we cover in the presentation are project timeline, responsibility, preconception, material reuse, testing, analyzing, and the reason behind our design decision.
In addition to all regulation, all bridges must be longer than 60 cm. The winning bridge are chosen by 3 criteria. The first one is strength to weight ratio, the second one is artistic, the third one is popularity of the individual bridge. As an engineer working on a project, we need to create project timeline and responsibility for all of our members to ensure that everything goes smoothly according to the plan and deadline. Also, all members will effectively spend their time and effort on the right track, as well as guarantee that we won't miss any important work. For the Spaghetti Bridge project, we've broken down the project into small tasks such as idea research, 2D design, construction, videotaping, and so on as listed in the Gantt chart and the responsibility metric.
Why do we use Limvannaksakpheabondith bridge as our team name? After research and discussion with among our team members, so we decided to use Limvannaksakpheabondith or Dam Bridge from Indian poem Ramayana. So we use Limvannaksakpheabondith bridge as our team name.
A bridge is a structure built to span a physical obstacle, such as body of water, valley, road, and rail. It is constructed for the purpose of providing passage over the obstacle, which is difficult or impossible to cross. There are many different designs of bridge, each serving particular purpose and applicable for different kinds of situations. And the first one is beam bridge. This type of bridge is simply supported bridge consisting of horizontal beam and 2 abutments or pier at each end. In this type of bridge, all forces are transferred to the beam and pier. This design won't survive on shoot alone since there aren't any trusses or cables that can transfer all the forces, both tension and compression, that acting on the beam. So if we want to build a very strong beam bridge, we will have to use a lot of spaghetti that will make the overall structure really heavy. So it's not a great choice.
The second is Cantilever bridge. This bridge works by using Cantilever, which might be beams or trusses. Cantilever bridges are constructed in parts and the 2 free and are connected with suspended deck. This bridge can be really strong and stable since it is supported by 2 supporting piers and batsmen. But the middle supporting pier is not possible for our spaghetti bridge challenge. So only 2 turbo as batsmen won't regret with this design.
The third design is suspension bridge. This kind of bridge held in place by vertical suspenders which support by the cables connecting between 2 towers. Any load applied to the bridge is transformed into tension across the suspension cables. And another design is called cable stay bridge. A cable stay bridge is dependent upon towers. Cables are connected from the towers to the deck of the bridge. While tension is constantly acting on the cables, there is only one tower to carry the compression force. It is not possible to build cable stay bridge or suspension bridge with the same reason as Cantilever bridge, since we cannot use piers that connect between the bridge to the ground.
So what possible?
There are 3 types of design that are possible. The first design is truss bridge. This kind of bridge are constructed by using trusses which are comprised of many small elements forming triangle shape. The role of this triangular element is to absorb tension and compression force that act on the deck. The second type of bridge is arch bridge. An arch bridge is a curved-shaped bridge where the load on the curve is not directly applied straight down, but instead, loads are carried along the curve of the arch to the end of support, meaning that no part of the bridge takes a high amount of pressure. And the last design is tight arch bridge. This is another kind of arch bridge, which is supported by vertical ties between the arch and the deck. The downward pressure from the arch structure to the deck of the bridge is translated into tension by the vertical ties. Before we finalized our bridge design, we did some more research on other projects. What we found was that most bridges use truss bridge or tie arch bridge, but it's still possible to design arch bridge, since there's one project built arch bridge using popsicle stick and survived a big loan. As in the project of Peter Sandor from Hungary, he succeeded to beat the previous world record in 2009 using tie arch bridge design that collapsed at 466 kilograms and the bridge weighed only 984 grams. And this is another truss bridge that was constructed among others at the University of the District of Columbia that weighed only 250 grams and it managed to hold 44 kilograms of load. Another project from YouTube channel, Vireakboth, using arch bridge with only 76 popsicle sticks and it has no problem under 42.5 kilograms of weight. At this point, tie arch bridge must be the best design, but there is one challenging problem that we need to consider. There are three possible options, which is truss bridge, arch bridge, and tie arch bridge. Finally, decision is being conducted based on three criteria, which is strength to weight ratio, construction difficulty, and artistic of the bridge. For truss bridge, from the point of view of strength, truss bridge provide a good strength to weight ratio and trusses can be easily conducted as well. With the right design, this bridge can have a very good image. Arch bridge also has almost similar strength to weight ratio compared to truss bridge. However, the construction isn't very challenging as well, but this design won't give good artistic since its design is too simple. Among the three options, most projects support that tie arch bridge has the best strength to weight ratio. Nevertheless, the artistic look is also greater than the other two types of bridge. The main problem is that it is very difficult to design and construction since it requires great technical understanding. We put everything into the evaluation table and it follows that the truss bridge has the highest score, in which it has a great strength to weight ratio and a good image. In addition, it doesn't require much effort for the construction, and our last decision is to pick the truss bridge for our project. And now it's time to design the truss. There are a variety of trusses that we can use, as you can see, and among all of them, flat truss has been used for over past 2 centuries as an effective truss method. So the vertical trusses are in compression, whilst the diagonal members are in tension. And another type of flat truss is called Pennsylvania truss, which looks just like a flat truss but with more trusses.
Thus, we decided to use Pennsylvania truss for our spaghetti bridge since it is an effective truss design from flat truss. Also, with the extra trusses, it will be able to hold heavy load on it. After the truss height has been chosen, we carefully designed it in AutoCAD using the right measurement with the exact amount of spaghetti stand for each truss to ensure that the construction process goes smoothly.
So now let me explain you all the material that we have used for the construction of spaghetti bridge. So the first one is Granero Bucatini number 11, which we use for main structure, and then Campagna Fettuccini number 8 that we use for slab decoration, and then we use glue gun, hot glue, scissors, rubber band, and this rigatoni pasta, which is one of the special techniques that we use. So let me illustrate this. We have tested a few times on its strength by connecting two beams together like this. And the result shows us that it's really weak at the joint part. Even though we attempt to use a big amount of hot glue, it's still the weakest part is still the joint part. So after that, we tried one technique of using rigatoni pasta connecting like this. It is a technique of beam supply connection, and the result is really impressive.
in the video, the original beam that we connected can hold up to 0.6 kilogram, while the beam that connected using Vireakboth pasta as an extra support at each joint, it can hold up to 1 kilogram of weight. So that's a huge 50% improvement. For step 1, we start by building the lower chord of the bridge. And since one spaghetti strand has a length of 24 cm and we want our bridge to be longer than 60 cm, we decided to connect 3 beams of 14 spaghetti strands forming 82 cm lower chord that supported or secured by Vireakboth pasta at each joint. For step 2, after we finish the lower chord, we start connecting the vertical member, diagonal member, upper chord, and post forming Pennsylvania trusses before connecting them together. For step 3, after 2 sides of Pennsylvania trusses are done, we start connecting them together with 8 horizontal beams and 6 diagonal beams forming the deck of the bridge.
Step 4, we finish the upper part of the bridge by using 8 strut and 10 total tracing the trusses and load to support the great compression on the upper chord. After that, for step 5, we use 5 lines of 82 cm vegetarian spaghetti for slab decoration. To finish, we glue it to the deck, forming the bridge slab.
So overall, the bridge has a length of 82 cm, has a width of 12 cm, and height of 15 cm. Our total expense is $18, and the bridge weighs about 0.81 kilogram, and it is expected to hold up to 15 kilogram of load. So this is the end for our presentation. Thank you so much everyone for paying attention and listening to our presentation. Thank you.